We're continuing 3.6 rational function yesterday. We started, I think, a few minutes of it, like 5 minutes, 10 minutes. So let's continue now. Yeah. Okay. Okay, where is my 3.6? Did I save it last time? Fresh notebook. I think I did. Did I save it last time? No, not this one. I always lose my 3.6. Where is it? Here? No. 3.6. Okay, it doesn't matter then. Let's just start a new one.
I think maybe you just continue with the 3.5, something like that.
You think so? Oh, yeah. Wait. Where is, this is 3.6, this is 3.5. Okay, see, I don't know. Yes, you're right. So this is 3.6, yes. Anyway, we talked about horizontal and vertical asymptotes. So let's write down how we found those horizontal and vertical asymptotes. Okay. So the asymptotes of rational functions all right. By the way, let me do one more before we grab these. So we have, we also have f of x is equal to 1 over x squared. All right. So if, before we talked about f of x equals to 1 over x, now this one is f of x is equal to 1 over x squared. Yeah. So the graph would look just like this. So what's the difference between this graph and the other one? It's always positive, right? So this is f of x is equal to 1 over x. So can you tell me for this graph, what is the horizontal asymptote? What is the horizontal asymptote? Which one? Which one? Which line is the horizontal asymptote? X-axis, which is what 0? 0 is a number.
Y equals 0.
Yes, y equals 0. Yes. So, and then it also has vertical asymptote. Yeah. Vertical asymptote is the y-axis, and the equation of the y-axis is x equals to 0. Right? Now, can you also tell me the domain and the range? So the domain is what? What possible x values based on this graph? Negative infinity to infinity? To 0? Yes. Negative infinity to 0, and then union 0 to infinity. Good. How about the domain or the range? Zero to infinity. Yes. All right. So the other one was not square, or this is 1 over x squared, not 1 over x. Yeah. So this is 1 over x squared, not 1 over x. 1 over x is one is on top, the other one is on the bottom. But for 1 over x squared, they both are on top. Both sides of the graphs are on top. Yeah. So now let's talk about vertical asymptotes. So we will we will use the reference of f of x equals to 1 over x and f of x equals to 1 over x squared a lot of times. So you need to know the graph of both, sort of. So how do we find vertical asymptotes? So suppose, let f of x is equal to p of x divided by q of x in its lowest term. Okay. Or then, how do I find vertical asymptotes? So to find vertical asymptotes, what do? We set the denominator equals to 0 and solve. Okay. Now, note that, so I'm going to put a note. Note, equation of vertical asymptotes has the form x equals to k. Okay. So you can't say, oh, what is the vertical asymptote? 5. So you have to say x equals 5 because 5 is a number. Yeah. All right. So this is vertical asymptote. Okay. So we set q of x equals to 0 and solve equation of vertical asymptote as the form x equals k because it's a vertical line. Yeah. Now, let's talk about non-vertical asymptotes. There are 3 cases for non-vertical asymptotes. Yeah. Let's see. So B2. So B2. Are you guys done? No? So non-vertical asymptotes all right. Okay. So there are 3 cases. So there are 3 cases. All right. So case 1 is when the degree of p of x is equal, less than, sorry, not is equal to, but is less than the degree of q of x. Yeah. So the degree of p of x is less than the degree of q of x. All right. So what you want to do is to give you an example. Y is equal to x squared minus 3x plus 5 divided by x cubed minus 4x squared plus 2. For example, okay. So what's the degree of the numerator here? 2? Yes. Thank you. So it is 2. So the degree is 2. Degree is 2. And the denominator? Degree 3. Okay. So what you want to do, this is also, you're going to do it in calculus later on. What is limit as x goes to infinity? Something like that. Yeah. So what you want to do is divide by, so only the leading terms count. So when we're talking about asymptote, only the leading term matters. So which one is the leading term? This is the leading term of the numerator. This is the leading term on the denominator. Yeah. So, so let me write down. As x goes to infinity, okay. So as x approaches a very, very large number, y approaches x squared over x cubed. So only the leading terms matter, and not the other ones. The other terms do not matter. Yeah. What is x squared divided by x cubed? 1 over x, right? So y approaches 1 over x, is it? Okay. Now, when I put 1 divided by infinity, so what happens to x? What happens to y? So meaning, or y approaches 1 over x. Yeah. Now, if I put a very large number here, what happens? So when x goes to infinity, y is equal to 1 over infinity. What is 1 divided by infinity? So 1 divided by a very large number, which is close to 0. Yes. Right? So if I have 1 divided by, for example, a very large number, what is a large number that you think about? I don't know how many zeros. So you have 0.0000000000001, right? And this is very, very close to 0. Yes. So y is approaching 0. Oh, this one is not equal to. So y goes to infinity, which means we approach 0. So in this case we have horizontal asymptote, which is y equals to 0. So this is case 1. If the degree of p of x is less than the degree of q of x, then we have a horizontal asymptote, which is y equals 0. Why? Because you have a 1 over infinity. 1 divided by a very large number is 0. So that's case 1. All right. So now let's look at case 2. What about if the degree of p of x is equal to the degree of q of x? All right. So case 2. The degree of p of x is equal to the degree of q of x. All right. So just to give you an example, y is equal to x squared minus 4, or maybe 2x squared minus 4, divided by 5x squared plus 3x plus 4. All right. So what happens as x goes to infinity? What do you think? Which one matter? Only the leading terms matter. Okay. So when x squared is going to be really, really large compared to x and 4, compared to 3x, compared to negative 4. So y will go to, what is it? 2x squared divided by 5x squared. So when you divide, what do you have? What is it? 2 over 5. Yes. Okay. So what is 2 and what is 5? 2 is the leading coefficient of the numerator, and 5 is the leading coefficient of the denominator. So in this case, y is 2 over 5. Yeah. So in this case, you still have a horizontal asymptote, but the equation is not y equals 0, but y equals to leading coefficient of p of x. So p of x is the numerators. Maybe I should just write numerator? No, we know what p of x is, right? Divided by leading coefficient of q of x. Why isn't it equal to 0? Why? Because the x's, what happened to the x's? They cancel out, right? Before, the x's do not cancel out. I still have one axis on the bottom, or one or more x's. It could be x or x squared on the bottom. But here the x cancel out, so I only have the coefficients. Yeah. All right. So if the degree of p of x is equal to the degree of q of x, then we still have a horizontal asymptote, and the equation is y equals to leading coefficient of p of x divided by leading coefficient of q of x. Yay, nay? Are we okay? One more case. Yeah. Actually, there are more, but the most common ones are 3 cases. Okay. So next one. Yeah. Okay, here. So case 3. The degree of the numerator is equal to 1 plus, so it's 1 more than the degree of the denominator. So for example, we have y is equal to x cubed minus 5x plus 2 divided by x squared minus 2x minus 3. All right. Yeah. So again here, which ones matter? The x cubed and x squared. But then what do you do when you divide x cubed by x squared? You have x. Okay. So as x goes to infinity, what happens? Y is approaching x cubed divided by x squared. So what is x cubed divided by x squared? Now, when I substitute infinity, then y goes to infinity. Yes, so when we substitute infinity, then y goes to infinity. All right. Now, so will it have a horizontal asymptote? No. Yeah. So no horizontal asymptote. Okay. But we will have what is called slant asymptote or oblique asymptote. Slant is slanted. Yeah. So we have what is called slant asymptote or oblique asymptote. These two things are the same thing. Interchangeable term. Slant is oblique asymptote, they're the same. Yeah. How do you find the equation? So to find the equation of the slant asymptote of the slant, so it's going to be a line. Yeah. Divide the p of x by q of x, and then we ignore the remainder. Okay. So that's what we're going to do. All right. So you have to divide the top by the bottom. and then we ignore the remainder. So remember, ignore remainder. Yeah, so should we find the equation of the slant asymptote for this? For our problem here? Yeah, so let's do this. Yeah. So what we're going to do is find the equation of the non-vertical asymptote here. And I know right away, oh, this is a slant asymptote. How do I know this is a slant asymptote? The degree of the numerator is what? 1 more. Yeah. If this is 2 more, you will not have a slant asymptote. You will have a parabolic asymptote. If it is 3 more, then you will have a cubic asymptote. Yeah. So it's not the line. If it is 1 more, so when you divide x cubed divided by x squared, then you'll have an x. So we will have a slant asymptote. What about if this is x to the 4 and this is x squared? What is x to the 4 divided by x squared? X squared, so you'll have a parabolic asymptote, etc. Yeah, but it's not very common. So let's just do with which is 1 more than the degree of q of x. Yeah. Okay. So let's do the division here. Can I use synthetic or do I have to use long division? Can I, in this case, can I use synthetic division? How? No, what I'm trying to do is divide these polynomial on top by these polynomial. Can I use synthetic division? No, why not? Because what? Why can't I use synthetic division? Because the divisor has to have the form what? X minus k. Is this x minus k? No. So I have to use long division here. Yeah, I cannot use synthetic division. So, for example, find the equation of the slant asymptote. So for this particular problem, we need to use long division. All right, because I can't use synthetic. So this is x cubed, and then what happens here? I'm missing a term, so I'm going to put in plus 0x squared minus 5x plus 2. Okay, divided by x squared minus 2x minus 3. All right. So how do we do long division? X cubed, bring down the x cubed. And then what? So this is not math 260. So if you forgot long division, it's not that you cannot do math 260. This is math 115. Yeah. So bring down the x cubed. So oh, that's right. That's right. Yes. So what is x cubed divided by x squared? So I was the one who forgot, right? Yes. So x times x squared minus 2x minus 3. What is that? X cubed minus 2x squared minus 3x. That's right. Good. So this is why we put in the zeros. So I could align the terms, the x squared with the x squared. Yeah, that's why we need to put in the zeros. Now, what am I supposed to do? So subtract. Instead of subtracting, I usually add with the opposite. So I usually use a different color, and then I'm putting this plus that. Yeah. Okay, so the x cubed cancel, and then what's next? 2x squared minus 2x plus 2, yes? And then what? 2x squared divided by x squared, which is plus 2x, yes? Plus 2, yes? Okay. Now we have 2 times x squared minus 4x minus 3. So what is that? 2x squared minus 4x minus 6. So you're multiplying it back to x squared minus 2x minus 3. Now we're supposed to subtract, right? But instead of subtracting, I usually add with the opposite. So add with the opposite. This is positive, the opposite is negative. This is negative, the opposite is positive, and this is also positive. So now I'm going to use my new sign. So 2x squared minus 2x squared cancel. Negative 2x plus 4x, 2x, and then 2 plus 6, plus 8. All right. Then what is 2x plus 8 divided by x squared minus 2x minus 3? Can we? No, so this is the remainder. Okay, good. So now what is the equation of my slant asymptote? Y equals x plus 2. Yes. And then what do I do with the remainder? We ignore it. Yeah. So this is the equation of slant asymptote. Yes, so far so good. So sometimes you can do synthetic, sometimes you cannot. In this case, you cannot, so we have to do long division. Because otherwise, if the divisor is x plus k, then I will just use synthetic division. Are we okay so far? Okay, good. So let's do a couple more, and then we will sketch. All right. So this is where the fun part is, because you get to sketch. All right. Are you guys ready? Okay. So, for example, maybe you're not. Let me put this back here. Yeah. So, for example, find the vertical. So, how many cases do we have for non-vertical? 3. Yes. And non-vertical asymptote. So they're not always horizontal. Sometimes it is slant. Yeah. All right. So number 1, f of x is equal to x cubed plus 3x squared divided by x squared minus 4. So let's factor them first. So we usually factor them first. How do I factor x cubed plus 3x squared? Yes, yes. Greatest common factor, x squared. We're left with x plus 3. Yes. How do we factor out x squared minus 4? X plus 2, x minus 2? All right. Good. Yeah. And let's see, can I cancel any terms? No. So this is in its lowest term. Yeah. If we cancel some terms, then after we cancel, then it's in lowest term. But here we cannot cancel any terms. Now from here, I could just write, well, what is the vertical asymptote? Usually I would just write as VA. So VA is for vertical asymptote. So what is the vertical asymptote? What is it? X equals -2? Yes. Or x is equal to 2. How do I get these? You set the denominator to 0. Okay? X plus 2 equals 0. It's x equals -2. X minus 2 equals 0. X is equal to 2. So we have 2 vertical asymptotes. All right. Yes? And I cannot say the vertical asymptotes is -2 and 2. You have to write it using equation. Good. What about the non-vertical asymptotes. What do you think? Do we have a slant or do we have a horizontal? Slant, why? The degree is of the numerator is 1 more than the degree of the denominator. So I'm just going to write that this is case 3, slant asymptote. You could write it or not write it as long as you know this is the slant asymptote. So what do you do to find the equation? Divide, yes. So how am I dividing it? We use long division? Okay. Yeah. We cannot use synthetic here, can we? No. Okay. So what do I write here? X cubed plus 3x squared plus 0 x plus 0. Yeah, because I'm missing the x and the constant. Divided by x squared minus 4. So on the right side, you have to align. That's why you have to put the zeros. What about here? Not really, because you're not trying to align anything here, right? So it's just going to be here. All right. Now, how should we do it? X cubed divided by x squared. X. So x times x squared minus 4. What is x times x squared minus 4? X cubed minus 4x. Oh, so I still have x squared here. All right, so subtract. So instead of subtracting, I'm adding with the opposite. So this is plus becomes minus. This is minus becomes plus. Okay, so this is 3x squared. What about this? Plus 4x and then plus 0. Okay. Okay, what do I do now? So divide 3x squared by x squared. So that is plus 3. Okay. 3 times x squared minus 4. 3x squared minus 12. And then we subtract. So instead of subtracting, we add with the opposite. So I usually circle my new sign. So I know that's the one I need to use. Yeah. So 3x squared cancel. What am I left with here? 4x plus 12. And is this remainder? Yeah, because you cannot divide 4x by x squared anymore. So this is remainder. So what is the equation of my slant asymptote? Yes, there you go. Doable? Yes. No. We just stop and then you just write down y equals x plus 3. So save time, right? Yeah. Yes. Good. Now we're sketching. Yeah. All right. 821. Let's see. I think the quiz is only, how many problems do you want? 1 or 2? 1? Okay, so it's only 10 minutes. Yeah. Yes. Okay, so now, next one, we're going to sketch. Yeah. So you guys remember the long division? Yes, you need to. Yeah. Because we use it sometimes. Not all the time, but what we use most was synthetic. Okay. So sketching graphs, sketching rational functions, graphs of rational functions. So what do you think we need to sketch? So one is vertical asymptote. So this is what you're going to sketch, a vertical asymptote. And then B, non-vertical asymptote. So always the question will ask you, given this function, what are the vertical asymptotes, non-vertical asymptotes? C, x-intercept. D, y-intercept. All right. And then E, this is important. Okay. So determine whether the graph intersects its non-vertical asymptote. The graph never intersects the vertical asymptote, but sometimes it intersects the non-vertical asymptote. So this is the important one. And then use additional points to graph. Right? All right. All right. So why don't we graph these? Let me see. How about these? Number 1. So do the A, B, C, D, E, F. And then this is the function. F of x is equals to 2x squared plus 10x minus 12. Okay. So I think we will finish tomorrow with 3.6. So when do you want your test again? Wednesday? Next Wednesday? That's not too long? So are we voting today? Okay, so Tuesday or Wednesday? So let's vote. So you have a choice. So we will have a test chapter 3 Tuesday or Wednesday? Tuesday, people? I'm going to count, okay? 3, 5, 6, 6 plus 3, 9, 9 plus 3, 12, plus 3, 15, and then 17. Wednesday, people? So 2, 5, I think less. Yeah, so we'll have it on Tuesday. Yeah, is that okay? So this is what you're going to do. You know how I provided the sample test? Where? On myonlinemath.com. You are going to work on those, right? I never collect the sample test, so it is up to you if you want to work on it or not. And then since we have a test on Tuesday, then on Monday, what's going to happen? The last 20-30 minutes, if you have questions, we will discuss it in class. Yes? Okay. But if you have no questions, I'm just going to go on with whatever lecture it is. And I'd really like you to look at it. And when you do homework, for example, for graphs of rational functions, I know in Math Excel it's easier. You can just choose without doing the steps. But it's really important that you do the steps. If you don't do the steps on the portfolio, vertical asymptote, those things, I will not deduct points. But for your test, when you graph, this is what I'm going to ask, A, B, C, D, E, F. Yeah? Yes? Yes, because I usually write down the steps, A, B, C, D, yeah. It should be there, yeah? All right, so Tuesday or Wednesday, yeah? So 2x squared, so it's Tuesday. We decided Tuesday, right? Okay. So 2x squared plus 10x minus 12 divided by x squared plus x minus 6. Okay. So who cannot come on Tuesday? Somebody? So you're doing it on Monday? Okay. Oh, you're doing it on Monday. But you could do it on Tuesday, right?
No, because I got classes all day long.
Okay, so you're doing it on Monday. Okay. Good. So 2x squared plus 10x minus 12 divided by x squared plus x minus 6. Let's see if we could factor this out first. What would you do here? So 2 times x squared plus 5x minus 6 divided by, is this factorable? What is it? X plus 3, x minus 2? Yes. How about the top? Is this factorable? What is it? X plus 6, x minus 1? All right. X plus 3 times x minus 2. Good. Yeah. All right. Now, A. What are the vertical asymptotes? So I'm just going to put VA, that's vertical asymptote. X equals -3 or x equals to 2. So we will box this. We're going to we will graph this. How about the non-vertical asymptote? Any idea? Which case is this? Case 2. Okay. So this is case 2. So y is equal to 2x squared divided by x squared. What is 2x squared divided by x squared? Y equals to 2. Box this. We're going to need to graph it. C, x-intercept. How do I find x-intercept? Set y equals to 0. So 0 is equal to, only the top matters. The bottom doesn't matter. Do you know why? So just say I put the bottom here, okay? Then what happens? How do you solve this? Multiply, or you could say I'm going to cross multiply. Yes. Or you say, oh, I'm going to multiply by x times plus 3 times x minus 2, right? But when I multiply the left side, so what will happen? It will be 0 anyway, so actually the bottom doesn't matter. So if you multiply both sides by the denominator, you still have a 0 on the left, so only the top matters. Yeah. So what is x equals to? -6, or x is equal to 1. But I'm not going to box this. Why not? Because this is not a line. Right? If I box x equals -6, what's the difference between this and x equals -3? Are they the same? No. So we have to write this differently. We have to write it as ordered pair. Because this is a point, isn't it? X-intercept is a point. So what are my x-intercepts? -6, comma, 0. What else? 1, comma, 0. So you got to pay attention, because otherwise it's really confusing. If you box x equals -6, later on you might draw a vertical line. Right? So I'm very picky on this, because otherwise it's very easy to make mistakes. So you need to write it in ordered pair. Yes? Okay. Now D, y-intercept. How do I find y-intercept? Yes, so x set x equals to 0. So f of 0 is equal to what? -12. So if I look at my original function, this will be 0, this will be 0. I'm only left with -12. And what about on the bottom? Yes, so this is equal to 2. So my y-intercept is 0, 2. Yes. Again, this is the ordered pair. So it's a point, We need to write it using ordered pair. Now E, determine if remember this is the important one, this is the one I put the star. If the graph crosses the non-vertical asymptote. So this is where I put the star. It's important when we graph. Right? How do you find the points? So basically you're trying to find the intersection. Do you remember how we found the intersection? How do we find the intersection between 2 points? So this is your f. F is 2x squared plus 10x minus 12 divided by x squared plus x minus 6. What is the equation of the non-vertical asymptote? Y is equal to 2. So how do I find the intersection between these two? You set them equal to each other. Yeah? So 2x squared plus 10x minus 12 divided by x squared plus x minus 6 is equal to 2. Yes? Okay. Now, this is a proportion. So this is 2 over 1. There is actually an invisible 1 here, so we could actually use proportion. You could actually cross multiply. So 2x squared plus 10x minus 12 is equal to what? 2x squared plus 2x minus 12. Okay. And then you say, oh, the 2x squared cancel. The negative 12 cancel too? Okay. So 10x minus 2x is equal to 0. So what is x? 0. All right. So where does it cross? 0, 2. So let me use a little bit. Yes, they intersect at the x is 0. What about the y? The y is 2. Yes. All right. So they intersect at 0, 2. Now we just have to graph using all those things that we know, all those wonderful things that we knew. Okay. So let's graph it here. All right. So what was the x-axis again? The asymptote? Oh, that's the big. Okay, so what is it? X equals to y equals to 2. So we need to graph the non-vertical asymptote. Y is equal to 2. All right. Then what was the vertical asymptote? X negative 3 and x equals to 2. Okay. So this is x equals negative 3. Y equals to 2. And then x is equal to 2 is right here. This is x is equal to 2. All right. Now, I'm going to graph all the points that I know. So it's negative 6, 0, so 3, 4, 5, 6. So this is negative 6, 0. And then 1, 0. This is 1, 0. What else? 0, 2? Yeah. 0, 2. All right. Okay, so how do you think the graph looks like? Do you have to choose additional points? You can, but do you have to? No, you don't. Okay. So I'm going to let you draw first, and then you need to pay attention. Yeah. Okay. Because you don't have to choose points here. We have enough points. Yeah. Ready? Okay. Now, I have a point here at negative 6,0. Yeah, on my left. What do you think happens? So basically, you have three different graphs because you have two vertical asymptotes, right? You have these two vertical asymptotes, and this is your horizontal asymptote, and you will have three different parts. So the number of parts depends on the number of vertical asymptotes. If you have two, then how many parts? One on the left, two inside the vertical asymptote, and then three on the right of the right vertical asymptote. Yeah. Now, let's see here. What are the possible combinations of this graph? What do you think? I know this is a horizontal asymptote, so it's going to get closer and closer to the horizontal asymptote here. Will it go here or will it go up here? Under. Why? It cannot cross, right? The only time it crosses the vertical asymptote is when? At this point. That's the only time it crosses. So it's not possible to have points here, right? Because if you have points here, then it means you cross, and there is no intersection here. I will intersect that, and that's not possible based on calculation. So I know it's going to be here. And do we know how the graph looks? And I know then it's going to go down here because this is an asymptote. So we're done with the left part. Do you have to be accurate, meaning like how close it is to the line? It doesn't matter. We're only talking about the general shape. Yeah. Okay. Good. Now, what about the middle? What do you think will happen here? Is it going to look like a U? Or is it going to start high and end low? Or what? How do you determine that? Huh? You don't have to plug in points here. Remember in the beginning, I have these two graphs, y equals to 1 over x. Okay, and what is the other one? Yes, y equals to 1 over x squared. So how does it look? Y equals 1 over x squared? Both positive. Yeah. Good. Now this is what happens. Now I'm going to look at x equals negative 3. So can you guys pay attention? This is important. Yeah. Which part gives me this line? Is it this one? Okay. What is the exponent? Or usually when I talk about 0, what is the multiplicity? Just 1, right? So it's odd. So it's going to behave more like this. Yeah. It shifted, but it's going to behave more like y equals 1 over x. What does it mean? If from the left it starts low, then from the other side it will start high. So the multiplicity, well, we don't call it multiplicity because this is not 0. The power of x plus 3 is 1, which is odd. So if it is odd, then it's going to behave like y equals 1 over x. What do I mean? Well, to the left of the asymptote and to the right of the asymptote, they will start at different places. So if this one up to the left, it starts low, what about the other side? Starts high. So you know it's going to start here. Yeah. So do you need to pick points? Not really. You can if you want, so it's going to look like this. All right. Okay. Now, how do I do the right side? Do I need to pick points? Not really. Then I will be smart here. Then I say, oh, this is my x equals to 2. This is my vertical asymptote. And then I'm going to look at my equation. Which one gives me this line? X minus 2? Okay. And what is the exponent? 1. Is it odd or even? Odd. So it's going to behave like y equals 1 over x. What do I mean by that? If from one side it starts low, what about the other side? Starts high. So it's going to start high here. So will it look like this? No. Why not? It cannot cross the horizontal asymptote. We already found out, we already established here, it only crosses at 0, 2. So how do you think this will look? That's the only possibility. Make sense? Okay. So y equals 1 over x is, I'm going to say different starting from left to right. I don't think we have time to have a quiz. Starting from left to right. Can we postpone the quiz till tomorrow? No. We have it in class. Yes. Different starting from left to right. What about this is even? So this is odd power. Yeah. And this is even power. What happens if you have even power, like x squared? So for example, x minus 2 squared here. What's going to happen? They start at the same starting point, right? Both high or both low. If you have even power, it's same starting point. What do I mean by same starting point? Both high or both low. Sometimes both low. Both high or low from both sides. Yeah. So if this is x minus 2 squared, then my function would look like this, because they both have to start low. Yes? Okay. I'm practically done with 3.6. This is all you need to know. But of course, we need to do a lot more graphing, right? But I'm practically done with 3.6. Yeah. Let's see. Should we do another one? Well, would you like to try? Why don't I do this? Why don't I give you a take-home quiz? Okay. 2 points, and then but tomorrow we still have a quiz. Yeah. Okay. So 2 problems, and we will discuss it tomorrow. So what about these? So this is what we will discuss tomorrow, but I'd like you to try it first. So f of x is equal to, do you want 1 or 2? 2? Okay. 6 over x squared minus 5x minus 6. And then you have the a, b, c, d, e, f, don't you? Okay. So number 3, f of x is x squared minus 2x plus 1 divided by x squared plus 2x plus 1. And you need to do from A through F, both. All right. Yes? So, can I say that this is due tomorrow at 7:45? So, due tomorrow at 7:45. So, please come not later than 7:45. Yeah, because otherwise I will say, oh, I already discussed it, and then you walked in and turned it in. I probably won't accept it. Yes? So due on Thursday at 7:45. So just say you cannot come tomorrow. You should email me. Take a picture and then email it to me tonight. Yeah, or anytime before 7:45. Yes? Can you guys do it? Yeah. So just say tomorrow suddenly you cannot come. You know my email, right? You do it, take a picture, and then email it to me, Siswanas faculty.laccd.edu before tomorrow 7:45. So there's no excuse. You're not doing your quiz.
Did you get my test, the last test you?
I think I forgot to bring it again. I graded them. I just forgot to bring them. I put it in my laptop. Can I email you the grades tonight, or you just need to see it tomorrow?
Just whenever you have it.
I have it. I have it at home.
Okay. And then the other thing.
Hold on. Can I?
Yeah.
Okay. All right, guys. We will see you tomorrow. Yeah. Let me stop the recording. We're actually done, but we will do more examples tomorrow.